Now in this session I will explain question number 3 and 4 of exercise 3.4 chapter 3 understanding quadrilaterals. Now in question number 3 we have explain how a square is a quadrilateral. Now if any polygon is considered to be a quadrilateral, so first of all we have to know what is the meaning of quadrilateral. So the quadrilateral means any polygon which is having 4 sides. Okay, the polygon with 4 sides is considered as a quadrilateral. Fine. So why square is a quadrilateral? Quite obvious. How many sides we have in square? 4. And this is why we say square is a quadrilateral. So what we have to write? So we have to write square is a quadrilateral. Square is a quadrilateral. Okay, square is a quadrilateral because it has 4 sides. So this is the reason that you have to write. Now let's move on to sum number question number 2. This is not A, perhaps it is sum number 1. Now let's see what is there in sum number 2. So why square is a parallelogram? Why it is a parallelogram? Now again we have to know the properties of parallelogram first. So in parallelogram what we have studied that the opposite sides are parallel and equal, and also the opposite angle should be also equal. So if these are the properties which matches with the square, so in square what happens? The opposite sides are equal and parallel. Fine. So this first property is matching. So now the second property is what? Opposite angles are matching. Opposite angles are what? 90 degree, 90 degree. So opposite angles are also matching. Fine. So in parallelogram, so the properties of the parallelogram is matching with square. So we'll consider the square as a parallelogram. Fine. So we'll say square is a parallelogram, but parallelogram is not a square. Just try to understand this. Why square is a parallelogram? Because all the properties of parallelogram matches with square. But if I say that if parallelogram is a square, then the properties of square will, all the properties of square will not match with parallelogram. Because in parallelogram all the sides are not equal. Fine. The diagonals, even we consider the diagonals are not equal. They don't bisect at right angles. So there are so many properties in square which will not match with a parallelogram. So parallelogram is not a square, but square is a parallelogram as because all the properties of parallelogram matches with square. Fine. So parallelogram. So square is a parallelogram. Why? Square is a parallelogram. This is a short form, short way of writing parallelogram because its opposite sides are parallel and equal, and opposite angles are also equal, and opposite angles are also equal. Okay, this is why we can say that square is a parallelogram. This question is very, very important, students. Now number 3 is why square is a rhombus. Now what are the properties of rhombus that really matches with square? Now in rhombus all the sides are equal. In square all the sides are equal. In rhombus the diagonals bisect each other. In square the diagonals bisect each other. In rhombus diagonals bisect at 90 degree. So those are the perpendicular bisectors. The same thing happens with square. In square also the diagonals bisect each other at right angle. So you see all the properties of rhombus are matching with square. So that is the reason why we can say that square is a rhombus, but rhombus is not a square. Rhombus is not a square because in square the diagonals are equal, but in case of rhombus the diagonals are not equal. In square, all the interior angles, the measure of each interior angle is 90 degree, but in case of rhombus, the measure of each interior angle is not equals to 90 degree. In case of square, it is 90 degree, but in case of rhombus, it is not 90 degree. So there are some properties of square which are not matching with rhombus. So we cannot say that rhombus is a square. But obviously, since all the properties of rhombus matches with square, so we can say that square is a rhombus. Understood? So the question can come in both the ways. So why rhombus? Why square is a rhombus? So we say square is a rhombus. Square is a rhombus because its all sides are equal. And diagonals bisect each other. Bisect each other at right angle. Understood? Because of these two properties, we can say that square is a rhombus. Now, this fourth part is why square is a rectangle. Why square is a rectangle now? Now, what are the properties you see in rectangle? The opposite sides are equal and the measure of each interior angle is equals to 90 degree. Isn't it? Opposite sides are equal. Each interior angle measures 90 degree. Even the diagonals are also equal. Fine, even the diagonals are also equal. So in rectangle, you see the mostly all the properties of rectangle matches with square. So we can say that square is a rectangle, but rectangle is not a square because in rectangle all the sides are not equal to each other. So if the question been asked that why rectangle is not a square, then what you will write? You will say that since in rectangle all the sides are not equal, so we'll say that rectangle cannot be said as square. Okay, so both the side I am giving you the hint. So square is a rectangle. Why? Because each angle measures 90 degrees. So you can write one property that square is a rectangle because its opposite sides, you can write this also, its opposite sides are equal. And each angle measures 90 degree. So with these two property, we can say that the square is a rectangle. Okay, so this is a solution of question number 3, students. Now let's move on to question number 4. Now, question number 4, what we have? Name the quadrilateral. You have to name the quadrilaterals, as we know that there are so many quadrilaterals. So, whose diagonals? Now, we have to see the properties of diagonals. Whose diagonals bisect each other. So, can you just name the quadrilaterals in which you find that the diagonals are really bisecting each other? And what is the meaning of bisecting? Bisect means dividing anything into two equal half. So, which are the quadrilaterals? Will fall under this property where whose diagonals bisect each other. So number 1 would be parallelogram. So in parallelogram, what happens is that the diagonals divides each other into two equal halves. The same thing happens in rhombus as well. Rhombus also. In rhombus, the diagonals also bisect each other. Number 3, rectangle. In rectangle also we see this property, and there is another quadrilateral is there, that is square. So these are the name of the 4 quadrilaterals where you will see this property is happening. Okay, that is in each of these cases the diagonals bisect each other. Fine. So number 2, what is sum number 2 we have? Perpendicular bisector of each other. Fine. So a perpendicular and also bisector. So these two are different words. See, bisector and also perpendicular. So a perpendicular bisector to each other. So you have to understand this question very properly. Now you see, you have to name those quadrilaterals in which you see that the diagonals are bisecting also, and also they are making 90 degree. Okay, since they are making 90 degrees, so we are saying perpendicular, and because they are bisecting and because they are dividing themselves into two equal half, so that is the reason we are using this word bisector. So both the things need to happen. That is, they have to bisect also, because we have already discussed these are the four quadrilaterals in which the diagonals are bisecting. But the question is, if they are making 90 degree also. Now I would like to show you one thing. Suppose this is a parallelogram. This is a parallelogram. So we know that in parallelogram what happens? The diagonals bisect each other. That means this diagonals, that is what they are dividing themselves into two equal half. But the question is, are they making 90 degree here? Are they making 90 degree? No, they are not making. But in some of the quadrilaterals, among this, there is some of the quadrilaterals in which they are bisecting also, and they are forming 90 degree also here. Okay, what are those quadrilaterals? So the name of those quadrilaterals are, first one is rhombus, and the second one is square. So this happens with these two quadrilaterals only, where they bisect also and they make 90 degree also in middle, in the center point. Okay. Now let's discuss sum number 3. What is sum number 3? Sum number 3, we have R equal. Now we have to say that in which quadrilateral the diagonals are equal, students, equal. Now as we have learned that in this four quadrilaterals diagonals bisect. Okay. Now in sum number 2 we have discussed in these two quadrilaterals the diagonals bisect also and they make 90 degree also. But now the question is, in which of the quadrilaterals the diagonals are equal? Okay, the answer is rectangle and number 2 square. So in square and rectangle the diagonals are equal to each other, students. Okay, so this is the solution of question number 4, and that's it for today's session. Try question number 5 on yourself. I believe everyone can do that. Question number 5 is very, very easy. But if in case you cannot do, then we'll discuss this during the class hours. Okay, so that's it for today's session. Thank you, students. God bless you all and stay blessed.